Hello everyone, welcome to Learn It All. I am software engineer in Microsoft. Today I wanted to share the easy problem which earlier asked in Google and Meta, that is merge two sorted list. Let's read this problem. So you are given the heads of two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. Okay, so you have to return the head of the merged list. So let's take the example. So they have given one example. So in that there is two lists we have get like 124 and 134, and the output it is given like 112344. So what they were doing, they were merging these two sorted lists. So yeah, so if you can see, this is the sorted with the like 124, the another is also like 134 is sorted, and they have merged it into the linked list. So this is the example, and so they have given one more, like the corner cases they have given like list is empty, both list is empty, then output is the empty, and it like one of the list is empty, then we are returning the another list. So these are the example. So let's see like how we can solve this problem. So if you might know, like if you have like the two only, don't consider now for the linked list. If you have like the two list, normal list or the array of the numbers, if you have like the 124 and 134, then how we can merge this, right? So that we can see, and then we can move to the linked list. Okay, so what we were seeing over here, we for the merging of these two lists, what we can see, like whatever the lowest node we can pick from the list and go on checking for the another node. So let's I have start from this number, and for the starting point of the both of the list, like the 1 and 1, so which is the lowest one, so both are the same, so anything will be the lowest over here, right? So we have picked this one. Let's say we have picked this one, then what we can do, we can shift to the 2, and in between 1 and this 2, the 1 is less, so we can pick the first number from the second list, and we can proceed further for the next element, which is 3. So in between 2 and 3, 2 is less, so we can pick this 2, and we can proceed further for that list. And from the 3, 4 and 3, the 3 is less, so we pick 3 over here, and we move to the next element. So out of 4 and 4, the both are the same, so we pick 4, and we are at the end of the linked list, or the null, or the end. We have already covered list 1, so whatever the remaining for the list 2, we just pick and add it over here. So this the merge list we were getting. So similar thing we have to do in the case of the linked list. What we can do, so over here we can pick this one, and that got added in the output list. Then we go for this in between like 1 and this one, the 1 is lesser, then we are going to the next element from 1 and 2. What will be the lesser is like the 1 number, so we have pick over here. Then we come to this point, so in between 2 and 3, the 2 is lesser, so we added the 2 over here. Then we can add we go to the next pointer, so 3 and 4, so in that the list will be the 3, so we have added 3 over here, and we move to this pointer, this node, and out of 4 and 4 both are same, so we can pick any one, and this it is like end of the linked list, and whatever the remaining part we can add over here. But in the case of the linked list, the catch over here is like we have to first find out what will be the starting point of that list, and that will be the head of the that linked list, right? So when we, let's say we have the so when we were wanted to start to solve this problem, we have to first find the new head of the linked list. So new head will be the whatever the smallest element in between both lists. So list is already sorted, so we have to just compare between these two nodes, and whoever is the least one, we just pick for the new head for that output list. Okay, and what we were doing over here, like first we have picked one, this one we have did, and like whatever the new smaller element we were getting, right, out of this 1 and 2, we were adding at the end of the list, right? Over here we have added to the next of this node, and we have to trace this node, and let's say this is like the tail of the node. So what we can do, we can like go traversing the linked list, we pick the tail node, and whatever the new node we were getting, we just add it into that list. So sometimes what the guys were doing, so they do like the tail node initialize with the null pointer, or the they initialize with the null pointer, or anything dummy pointer they have initialized. So there are the both ways. If we initialize with the null pointer, then what we can do, so whatever the new node are coming, so we just pushing it into the tail's next element. Okay, like the tails. So whatever the new node will come, we just put, so that is 1. If 1 is coming, then we put it into the next element, and we update our tail with the tail next. So let's see it once again. So in between this, so if let's say take we example like if the tail is like, if we pick it as a null pointer, okay, or dummy pointer, anything you can work. So let's, if we do for the null pointer, then for the earlier stage we have one of our pointer iterator is at this linked list 1 and another iterator is as the second list. Okay, so in between these two lists, whatever the list, the smaller number that we can pick, so one is smaller. So in that case what we can do, so if tail is already null, then in that case we can update tail with the this node. Okay, and we move to its next node. Okay, and if it is already means if it is not null, maybe in the case of like in middle case of that thing, so if we are like in 2 3 case, so 2 is smaller, so we have already tail we have, so tails next we put it as a 2 node. So let's I will explain this with my whiteboard. So this is the whiteboard and I am picking the linked list over here. That same example we can pick, and we can have this linked list 1 2 and its third element is 4, and we have the another linked list 1, then 3, and then we have the 4. Let's take the 2 pointer over here. Let's say I have picked the p pointer over here which pointing to the 1, and there is q pointer which is pointing to the 1, and whatever the r which is we are going to return as the head of the linked list, and I'll use one more tail pointer, so that what if it used for, so tail of the linked list. So in between these 1 and 1, so we can compare the both of these things. So 1 is like the lesser, both are the same, so we can pick any one. So we pick 1 and tail is already empty, so we just assigns the tail with the 1. Okay, and whatever the result we were returning, so we were added into this r pointer, so head pointer. Okay, and we can move this to the next node. Okay, so now p is looking to the this second node, and in between like 1 and 2, 1 is lesser, so we have already tail node, right? Tail node is not empty, so we can, what we can do, we can assign this 1 to this tails next, and now tail is assigned over here. Okay, so let's erase this. Okay, in simple words, like our new list will coming like this, and our tail node is now at here. Okay, and its next is null for now, and q is got shifted to the next pointer. Okay, so in between 2 and 3, 2 is lesser, so what we can do, we can assign it to the tails next. Okay, so we will assign 2 over here, and we will assign tail is got updated for this 2. Okay, and then we can move our pointer to over here, right? So in between 3 and 4, 3 is lesser, so we add that to the tails next, which is 3, and that our pointer points to the 4. Okay, so in between 4 and 4, any one we can pick because they are same, so we pick 4, and now p is now at the null pointer. So list 1 gets completed and list 2 is currently there, and so whatever the element are present, we just append for the list 2. So whatever, if anything appeared for the next of this linked list like 5 6, so that's got appended by, like, we have the tails, and tails next we can assign it to this 4, so that 4 5 6 gets appended. So let's solve this problem using C++. So if you are familiar with any other language, then don't worry about that thing. So whatever the linked list logic you have, you can add over here. So I will formulate the pseudocode for this so that you can write your code in your own languages. Okay, so let's see how we can solve this problem and code this problem in C++. So before that, we have like some corner cases they have already given, like both of the pointer is like null, then we were returning null pointer, and one of them is like a null, then we were returning the pointer. So what we can do, we can check any of these is null or not. Okay, that will be our corner case. And in that case, so if list 1 is null, then what we can do, we return list 2. Okay, so list 1 is null, we just return the list 2. So there no processing is required for that, so we'll just return that thing. And if list 2 is null, we will just return list 1. So you might think about, like, if list 1 and list 2 both are null, then what will happen, right? So both are null. In that case, like list 1 is already null and it got passed, and it will return list 2 which is already null, so it is returning the list 2. So these all the corner cases gets updated. Okay, and we can say that, yeah, so whatever the result we have, we are going to store it into this list 3. Okay, so this is the list 3, and what we can do, we need one more tail pointer, right? We can assign it to the null pointer. Okay, and what we have to do, we want some pointer for the list 1 and the list 2. right? So what we can do, we take like we can reuse this pointer, but the best way is like you can create like use the separate pointer, like something like current one which assigned with list one, list star current two. This is assigned to list two. So you might ask like what the current one and current two is coming over here. So if you see this diagram, so whatever the P and Q we have taken, so that one is like the current one and the current two, okay, and that we were traversing, and the list three is this the R pointer, and T is like the tail pointer over here. So that I hope that will be not a confusion for you. And what we can do, we have to traverse all the linked list till it's one of the linked list gets null, okay. And so before traversing means like our tail is like already null, right? So we will take care that case in the below. So if we consider like if current one's value is less than current two's value, so in the case of less than or equal to, so in the case of like less than or equal to, so because like in both these language means the list, the one and this one pointer, both are their values are same, so we have picked any of that thing, so we have picked this one, so we have added over here. So that's why I have taken like the less than or equal to. And what we can do, so we have to update this current one, so current one value will have to update to the tails next pointer. But before that we need to check like what we can do. We can check tail exactly equal to null, then our means like in the initial stage our let's stays empty, so in that case we can assign it with like tail with like current one, okay. And we have to go ahead for the current one next value. And what we were missing over here, we have to update this list 3 pointer, which is the our head of the resultant linked list, okay. So we have like list 3 is equal to tail, we have updated, and you might wondering what will be the list 3 is like we at the end we were going to return this thing, okay. So this is for the like if we have the tail pointer as a null, and if the tail is not null, then we can assign it with like tail's next pointer, we can assign with current one, we can update current one with the current ones next, okay. And we have to also update like tail of our linked list and tails with the tails next node, right? So tails we have updating because like after like we have added one, so we have added one, so when the case of 2 coming, so we have moved this T to this node assigned to the latest node, which is like we were keep ourselves the tail of our linked list. So yeah, so I will repeat this thing like for the current one value is less than the current two value, then if the tail is like the null pointer, then tail will assign to the current one gets updated to the currents next, so that like so we have picked this one, so we have to move to the next element so that we can check for the next elements. So tail is already null, so we have to update the resultant linked list head node that we have did. In the similar case like over here we have to update it with like tails next pointer, we have to update current one with the current ones next, and we have to also update the tails node. And in the else case we have to do it for the same way but for the current two case, because current two is now less than the current one. So in this case like we have to just update with this with the current two, and list 3 is updated with the tail. I'm just replacing current one with the current two, so that like current two and like are here current two, okay. So this will work and this will like do for that thing. So what we have did is like we were checking current one and current two, so we were using the and over here, and so whenever like we were using and, so we were considering the both of the linked list node whenever we were traversing anyone will go to the end of the linked list, and we have to append the other what remaining linked list. So in the case of this example, so we are already completed this linked list and our p gets null, so but still we were remaining with these of the nodes. So what we have did, so whatever the new node is coming, so we update means add this node to the tails next node, so that they are already linked, so that got added over here. So we not required to add each of that things, so that we can append remaining part of the both the whatever the remaining list. So that case we have to consider like if like the current two is still there, okay, or we can say current two is not equal to null pointer. So in that case what we can do, we have already tail, right? So tails next we will update it to the current two, okay. And in the like the case of if current one is not equal to null pointer case, So in that case, what we can do, the tails, next we will assign it to the current one, and at the end we will return list 3. So I hope you understood this question and understood the logic whatever I have written. So I will just try to run this problem, and I hope it should run with our input test list, and we have the test list 124134, and all are gets accepted. So the best way is like we can check and add our test cases over here. Let's I have added something. I will modify it with like 5, 6, 7. Okay, I can also modify it with like 8, 9, 10, and 6 over here, and just the node. So some test cases I have added, and I'm just trying to test this so that like we can confident with our code, and test cases got executed, and we have our test cases are looks good. So let's submit our example. So our gets accepted, and we have achieved 100% of our result, and we are good to go. So our code is excellent, and it is having lesser time complexity because it builds the 100%. Okay, so this is like the one way of solving this question for merging two lists. So this is like the one of the like iterative approach, because we were going on like iterating each of the node, like we have picked this node and this node, and in the iterative way we were traversing both of the list and giving the answer for that. So there is also like the recursive way of solving this question, and I'm going to explain that in the next video. So if you want to see that approach also, then you can see. So both approaches are good, and like for your understanding of the concepts of the recursion and these things, you can watch that video also. And thank you for seeing this video. I hope you understand this thing, and if you understand this thing, then please write a comment that you understand this thing, so that I can know that yeah, my efforts are going good. So thank you very much. Yeah.